Hi, everyone. Thanks for coming in. Yeah. Good morning, everyone. Thank you. Hi, everyone. Welcome to Innovation Week. We have a really nice panel set up for everyone. This morning, this whole day actually is sponsored by the National Innovation Network. And so we have Mike Dodd and a lot of other great panelists here today. There will be talking to you about the National Security Academic Accelerator and IU Award. And I think you'll have a really great talk. Everyone, please put your questions in the Q&A portion of your Zoom window. The chat goes to the panelists, so the Q&A allows them to see, allows all the attendees to see your questions as well. And with that, I'll hand it over to Jeremy. Thank you.
All right, thanks so much, Melissa. I'm Jeremy Brilliant. I'm managing partner at Dioltas. We're a disruptive technology defense consultancy, and we have the pleasure of working with academia, the Department of Defense, and industry. We forge meaningful partnerships and create real change. And as Melissa said, we have a great panel with us today. Mike Dodd is Indiana University Program Manager for the National Security Innovation Network, also known as NSIN. That's a program of DoD under the Defense Innovation Unit. Also joining us, Dr. Jeff Zaleski, IU Interim Vice Provost for Research. And last but not least, Dr. Mehmet Dalkilic, who thankfully also goes by the name Memo. He is IU Director of Undergraduate Studies for Data Science and Associate Professor of Computer Science and Adjunct Professor in Statistics. And before we kick off our conversation today, I want to show a brief video that will kind of set the stage for what we're talking about.
How do we disconnect business? How do you bring in academics who are doing research in hypersonics and additive manufacturing, AI, machine learning, that all exist here, and bring them into the ecosystem? And how do you deal with the companies who traditionally haven't wanted to do business with the federal government, right? The administrative barriers are so high that they just stay away from it. Young startups who are bringing some of the most innovative tech to the warfighter. How do you just navigate that, bring everybody together, join teams, and offer solutions so we can collaborate?
I think that does kind of set the stage for what NSIN is all about, Mike. We just heard from you talking about it, but if you could again just kind of talk about what is NSIN's role at IU and other universities across the country.
No, thanks, Jeremy, and thanks, Jeff and Memo for joining today, because this is important and / personal for me. You know, having served in the Marine Corps and been a forward deployed Marine around the globe. Trying to actually bring best-in-class solution sets to the warfighter is a big passion for me. So I appreciate the opportunity to collaborate with IU and Memo on this team. So NSIN, very holistically, we build networks of innovators that generate new solutions for national security problems. So we're very focused on our activity with academia, non-traditional defense companies. And if anybody out there is asking what's a non-traditional defense company, you are one. And institutional finance, where we can bring scale to activities. We've got 3 lines of efforts: in our portfolios, national service, collaboration, and acceleration. And most recently, we recognized that we needed to create a national security academic accelerator. So our new program, NSA2, that seeks to establish T3 pilot partnerships with universities that will ultimately spin out new dual-use ventures based on existing university intellectual property that align to a topic area or technology focus for one of our DoD customers, and in this case, Naval Surface Warfare Center Crane Division. One of the things that's also really important to this discussion is, you know, I am with NSIN and at IU very purposefully So, NSIN didn't send me down there to, put a line in the water and hope I was going to catch some fish. They sent me there to spearfish and recognize that IU and the ecosystem there have tremendous capability, and we want to connect it into DoD problem statements. So as we decided to kick off with NSA2 and that topic area, which Memo is going to wade into here in a couple of minutes, again, very purposely looking at capability on campus and in the ecosystem and how we converge all that and get it into this funded program. So we were really pleased when IU submitted and won a most recent award in our NSA2 program. So those are the broad strokes, but thank you, Jeremy.
And Jeff, I think what Mike's talking about aligns perfectly with the goals of IU as far as working more with DoD. How does this align with those goals, and why is this good for IU?
I think IU is really, as most people should know, has considerable strengths in high performance computing and areas such as AI within the Luddy School of Informatics, Computing, and Engineering. Much of today's sort of cutting edge DoD research is really founded in areas that are non-traditional, things like AI, cybersecurity, hypersonics, and even quantum information science. Moreover, considerable DoD research is really based just in engineering in general. And the founding of our intelligence systems engineering program about 5 years ago now really has opened the door for IU to be able to compete and in this space and at the intersection of things like high performance computing, drone research, and autonomous vehicles. So I think that's really opened the door for IU to be able to play in this space. So as far as the landscape goes of our current capabilities, we are now a much better fit for typical DoD interests. Finally, I would say that the percentage of the research budget that comes from DoD, that IU has been involved in is typically pretty small relative to other Big Ten schools and other AAU counterparts. At some institutions, DoD funding is really eclipsed, like the more traditional NSF or NIH funding streams as their number one source of funding. And IU is working toward that type of a goal. So we'd really like to diversify our portfolio more, and get more of our appropriate researchers that we have, people like Memo and Phil Risherm in quantum information sciences, who's on this award, into these areas and into these opportunities, especially as we continue to play a leadership role in high performance computing, AI, and quantum information science.
All right, thanks very much, Jeff. And just a reminder, everyone, again, if you do have a question at any time, you can just click on the Q&A button below, submit your question, and we'll get to those as we're able to. But Memo, we want to talk to you now.
First event file being muted. There you go.
Can everyone hear me now?
Yes.
Okay, sorry about that. Yeah, I just wanted to remind everyone that you can click on the Q&A button at any time if you want to submit a question. We'll get to those questions as we're able to. Memo, we want to go to you and talk about your experience this past summer with NSIN externs, that award that Mike and Jeff mentioned, that National Security Academic Accelerator, the NSA2 award that you received. Tell us about that experience, the value of that, and how that was for the students.
Sure. I actually have a few slides to show while I talk about that. So the XForce project was over the summer with NSIN. We were a group of 4 students, 3 undergrad and 1 grad. Luckily and fortuitously, 3 of them were from IU and 1 was from Boulder. We had 2 women and 2 men, and I just wanted to highlight again this triumvirate partnership between NSIN, Crane, and IU. I've been at Crane now for about 3 years as a visiting research faculty, and so this harmony of these 3 coming together has really made a profound impact on just my work, being able to work on projects that typically wouldn't fall under the normal sorts of things that I would do as a data scientist. And I wanted to echo what Jeff said. Our infrastructure here is honestly premier. We have now the one of the I think for university-owned best supercomputer in the nation for academia, and so everyone has free access to this. So there's lots of materials and a wealth of software that we can take advantage of. So this is NSIN's beautiful slide talking about what they do. So for the summer, XForce, they asked for some proposals. I gave a proposal. I was a little bit hesitant in providing my proposal, not because I didn't think it was good, but because I'm a healthy skeptic as a scientist, and began probably with a little bit more of a rant than actually a proposal. And that was because I visited Quantico and watched some war games with technology, and found that from my perspective, the technology wasn't being leveraged in a way that I thought was most effective for the warfighter. So I usually do a penny test, and you put the penny at the top of the organization, and then it should land in the hands of the people that actually use the technology. And so what we wanted to do was rethink how to use drones. So this is the outline of the talk, by the way. I'm the keeper of the slides for whatever reason. So I will be talking about this system that I proposed, the RADIS system, and it's going to be at a high level. That's because too quickly I think we professors get into the weeds because we're excited about the details, but I think what's most important is to describe how exciting it is to work on a project that not only involves theory, but also practice and engineering. So the first thing I'd like to point out is that there is an overwhelming increase in the amount of data, and now we're going to be talking about zettabytes. And as you can see at the top, that's a very large amount, and by 2025, it will simply overtake us. And it's claimed that 42 zettabytes would be enough memory to contain all of human speech that's ever been uttered. And as you can see from on the panel on the right, all the types of information that are inundating the warfighter, these are meant to provide better decision making. But we as humans really have a limit on how much information can come. And my proposal was that instead of using drones as elements of swarm computation, where you would optimize some sort of problem, that they would become an asset and help offload this amount of data. And Feynman, some time ago, actually in his lectures on computation, was very prescient and said that he believed in the future that the time of computation would be actually overwhelmed by the movement of data rather than the computation of data. So in part, what we were, the project was suggesting was, let's use drones as a way to offload some of this inundation of information to help the warfighter make better decisions. So typically, oh, this is my team. You asked to talk about XForce. So Brady Anderson and Arthur Hertz are in the Luddy School in CS. They're both sophomores. Paula is a graduate student in ISE. Her undergraduate is in physics. And then Logan is an aeronautical engineer. She is a junior at UC Boulder. We also worked with Dr. Ben Connolly, who's now been promoted to a program manager for the Navy, and Maxwell Lombardi, an engineer. And then we're working with a programmer, excellent, a former student of mine, Scott Beeson. So our goal was to make what I'm calling, and I know this is a loaded term, a rational asset. So the idea is that the drones would be something that would offload the information and help relieve the warfighter of mundane tasks and let the warfighter work on critical elements that AI and machine learning simply aren't well suited for. And the simple task that we had was this: we have a base, and it could be any location, and then we have a target. And what we would like to do is have the drones find the shortest path to the target. Now, because of COVID, we weren't allowed to meet. So we turned this problem actually into a part of the solution. So our idea was to create two things: a simulator that would allow the Navy to plug in different types of drones with different types of sensors, and to run these procedurally generated maps to see how effective the drones were working. And here are some elements of the problem that we're solving. We have what are called static blockers. These are things that are permanent, since the combat environment is going to be changing. So you can imagine these as buildings. So the drone simply can't fly up 10,000 feet. They're going to be navigating. Then we have dynamic blockers. These are things that are moving. This happens in real combat, and it may not be even enemy, just a train or a bridge moving, or closing or opening. Then we have what are called hot zones. These are zones that would degrade the drone. So the drone actually has self-awareness and knows that something is happening to it. So depending on how critical the mission is, the drone either will go through this hot zone, or go around it, or return. We modeled the hot zone as just a linear function. It degrades 10% every 2 widgets of time or so forth. Then we have dead zones, which are places where the drone's sensors are not working. So the drone has to make critical decisions on how to move from the base to the target. And the drones communicate with each other, and they communicate with the warfighter. So they form a team. So as you can see, they're self-aware. They're also mission-driven. So this is one of the tasks that we really wanted to engage in and make sure that we achieve this, because as the technology improves in terms of these autonomous vehicles, they're really unaware of the task that's involved with the warfighter. And we wanted to make a simple task. Obviously, we'll expand from this, but here we simply want to move from base to target. And we added rational. So inside each drone is an assessment of how critical the mission is, whether the drone can actually successfully fulfill the mission, and its needs. So for instance, fuel, if it only has a quarter amount of fuel left, and it won't be able to succeed, so it would return to base. It doesn't need to talk to a human. But on the other hand, if it's very critical, perhaps we would send the drone in as far as it can go, and then relay back the information. And there's a lot of communication. None of the drones hold all the information. We assume that that's back at base, and then they interact with the warfighters. They're able to give the terrain that they've explored, and find the shortest path for the warfighters to get to the target, which might be a new FOB or a drop zone of some kind. We were sort of agnostic in terms of that. So we created 4 simulations that I'll show you, but the idea is that these drones fly around to the target. We used Euclidean distance instead of Haversine. We would use Haversine in the normal circumstance, obviously, but because of the distances were so short, and the amount of fuel that we had limited the range. We decided to use Euclidean distance, but we were able to create 4 simulations, the software system Radis, that improved on adding different elements of the drones as they worked together with the warfighter to find this shortest path. All the information too, because I'm a data scientist, is uploaded to the cloud. So we can learn and examine what happens when the mission fails, let's say, or the mission is a success. What kinds of things can we engage in to improve on the next iteration? I have always thought that you should never repeat the same mistake twice. So here are some snapshots. We did this in Python, which we normally wouldn't do. We would write it in C, but Python was easy to do visualization. The first map is showing A-star and Dijkstra's algorithm. We ended up with a form of A-star and moved to pose to create a continuous space. These are 3 of the 4 simulations. The last simulation here, the agents are actually sharing elements of the map and finding the shortest route from the target to the from the base to the target. And these blues represent the static blockers, and the red represents the hot zones. We have moving targets too that are green, but we didn't plot them on these targets because I didn't want too much busyness on these maps to show you. So the idea is also that there is a way for the warfighter and drone to talk to each other without using anything very complicated, because obviously there's memory resource limitations, time resource limitations, and this is where I think as an academic it becomes very exciting. We have theory, so there's a theory, let's say, of A-star finding the shortest path, then there's an actual putting it into field and watching it work. So at this point, we added, the last simulation, we added noise to the sensors. Some of the sensors failed. So this is a normal type of scenario that the theory typically wouldn't talk about. This is describes basically the project that we have. So we finished with a force simulation that we now will take and build physical drones. So we have a team assembled to put together the drones. Again, it's we have to reignite the mission because simulating in silico is much different than actually engineering elements in the field. So we will again start essentially from ground zero, but compare this with the simulation that we built and then improve the simulation as we improve the physical or tangible embodiment of the drones, and then have 2 products. So we'll have the Radis software system, and then we'll have these rational drones that will help find shortest path to a target and create terrain maps in unknown regions.
Thanks so much, Memo. Mike, I want to ask you, so many times a program's goals and the outcomes don't align. What Memo is saying has got to be music to your ears as far as what DoD was hoping for, and then what has come from this is really remarkable.
No, absolutely. And one of the most important things about the NSIN portfolio programming is multiple lanes of the programming can feed into kind of a next iteration or next level. So, the XForce Fellows program, summer program, problem statement from a DoD sponsor, that team will work on it guided by, a faculty member, and depending on some of the inputs and milestones the team makes, we start to orient them toward follow-on programming. And in this case, XForce Fellows leads right into, NSA2 by design. So the intent of our programming is to do just that, to be enablers and feeders into our follow-on programs. And then ultimately, we're looking for actual solution sets. So the NSA2 program is not just funded research that we're kind of iterating back and forth with the program manager and the DoD end user. We're actually looking for that research to turn into an actual company that we will get compliant credentialed to do government contracting and be able to deliver that solution to that DoD customer. So you're going through, and if you look at just the timelines on this in typical Department of Defense acquisition, to go from a 10-week fellowship, a break, request for solution response award into a follow-on program, and all of this you're going to do in under 6 months. And toward the end of this cohort, having an entity formed that's compliant, credentialed, and have an acquisition path to a government program of record customer is really not been done before. So NSIN's bringing tremendous leverage to bear, for DoD and academia, and getting these dual use entities formed and engaged.
And then Jeff, how does this NSA2 and everything that Mike just talked about and Memo described, how does that align with IU's overall strategy when it comes to defense?
Yeah, that's a great question. And I just want to expand on what Mike said and thank Mike. Mike has really helped us see other DoD opportunities that are now available for some of our researchers like Memo or Phil Risherm in quantum information sciences. So back in June, we were alerted by Mike to an RFP that was coming out for this National Security Academic Accelerator. And we were asked to respond to the RFP. And so what isn't really clear in the conversation, I think, is that the RFP is sort of a dual mode RFP. Part of it is the science and the research to deliver the product that Memo and Mike were just talking about. But the other part of that is to build an infrastructure and essentially a resource that would then bring in additional variants and additional science and research that would turn into products, sort of in a conveyor belt type strategy. And so Memo is really the first, and Phil is essentially the second of these two areas and these two researchers. So we've got now projects in machine learning and AI, as well as quantum information sciences, and we're lining up the next 5 or 6 technologies that we're going to try to move through the accelerator that will ultimately match with DoD customers. As part of that activity, we've also begun to generate an off-campus installation that would sort of serve to help these types of projects and these types of customers come together for DoD work. And the hope is that within a year, we would actually be able to have a space that we could bring the customers and the academics together to talk about real DoD problems and solutions, potentially even in a classified research or a controlled unclassified arena. So, this sort of new strategy really gives our researchers a legitimate footprint and connectivity to the DoD research arena that they really haven't had a chance to compete in the last decade or so. So it's very exciting for all of us.
And
Jeremy,
Memo,
if I could just quickly add to that before we go over to Memo, because this, I think, bolts on nicely to what Jeff just described, is I talked about kind of this acquisition path. And a lot of times what academics don't fully get their arms around, is DoD acquisition. But in this instance, when we're forming these entities who will then be performers to the Department of Defense, we're also looking for those entities to have that reach back engagement with the university that help birth them, right? So as we look to scale and access follow-on R&D, it's that close collaboration between the new co that's formed and its connectivity to the university and the labs that are going to actually help propel and scale that entity for the DoD in and of itself. So when we create, this NSA2 award, that's a contracting path for both this new co that will come out and the university, because those will drag along together as that engagement continues. And as Jeff mentioned, create that pull and demand signal for additional research and topic areas from the university to pull through that vehicle as well. So it's critical to the ecosystem of how we go from funded research to an entity to delivery in DoD.
I almost look at it like I'm just writing down a couple of notes here, and I just wrote down, that IU is creating a factory for DoD innovation, which is essentially what's happening here. I mean, it's just kind of this continual building of ideas that DoD is really going to latch onto. Memo, if I could ask you real quick, putting myself in the shoes of a student who went through these programs, I mean, what was it like for the students? What was their experience? They were solving real world problems. And you're muted. There you go.
I didn't get to speak about that, but we met 2 or 3 times a week over the summer, and I would say at first the students didn't think that they could do as much as I had proposed, and by the end all 4 wanted to continue working on the project, and they were able to do some amazing things. What I loved about the group too was the diversity. So having an aeronautical engineer from Boulder, and then a physics major who's in engineering, and then we have 2 computer science students. This group was able to leverage the strengths of each other. And what I purposely did was pair different people together as we worked through the different months, so they could learn each other's language and see different perspectives on how we could get this project running. And what I didn't talk about is the number of failures that we had. So, but I think this is part of the exciting element of engineering, is that there are things that we conceive of and that we can imagine, but then when the rubber meets the road, you discover that you have to use some duct tape and some paper clips to get things to work. So we actually did 180 degrees in terms of how we ended up simulating the search, and it was a wonderful experience. All 4 now want to continue with, in some respects, with the DoD, and are excited about this area. And for me personally, I've not had this much fun, frankly, working with 4 students over the summer, and I didn't expect much. I'll be candid. I have PhD students, and these are undergrads, and what I discovered was they were hardworking, conscientious. The students that NSIN selected were amazing. I was lucky that 3 of them were at IU, so it made it a little bit more local, but since I have some connections in Boulder, it was nice that I had a student from Boulder, but it was amazing. And I would say the output of the project actually exceeded what I had proposed, which was something very exciting for me personally as well. I think one of the challenges we face in academia is that since we worry about research, the time frame typically is a little bit different. When you have to produce a product that's going to be in the hands of someone in a year, I think it's a dog time. So divide everything by 7, and so it gives you a different kind of satisfaction. So it was an amazing experience, and I'm still in contact actually with the 4 of them, and they keep emailing, when are we going to begin? When are we going to begin again? Because they want to see this through. And I would say even for themselves, they discovered new talents and strengths. The aeronautical engineer really didn't do much programming before she began. Now she's doing some programming. The physicist did an amazing job, again, doing simulation, and the 2 sophomores who only had 1 semester of programming honestly did an amazing job. We did everything with best practices using Git and versioning, and we tried to stick to everything that was professional. So even for the cloud, we created a database to keep the information, and looked at how to design an information system from scratch that would be commercially viable. So yeah, it was a wonderful experience, wonderful experience.
And Jeff, Memo brings up a great point of the speed of all of this, and how quickly, you know, they're able to start with a problem and then come up with a solution. And that must be great from IU's perspective as far as communicating to prospective students or prospective grad students, perhaps, you know, that this is a place where things are happening. You want to pay attention to this. You want to be a part of this.
Yeah, for sure. I mean, students love nothing more than to make an impact and to have projects and things that they can work on a team that is going to have some big outcome. I mean, that is their favorite activity. So I think that definitely is the way work is getting accomplished these days. It's the way work will probably become accomplished when they leave, and it's a good way to begin to train them. So I think from all points of view, it's a good outcome.
And Mike, Department of Defense, and one of the things that impresses me as maybe just a taxpayer is that the government is looking outside of the government and saying, hey, we don't have all the answers, and you know, we want to find the best solution no matter who has it. So that's what's happening here. And then what's next? I mean, there are so many different topic areas that are important to the government, to the military. What do you foresee the next 6, 8, 18 months even for IU?
No, sure. And part of that points back to what Memo mentioned. So the teams that we put together, we get a problem statement, align it to the university, and we get our student submissions is, again, by design, ensuring that the teams are completely interdisciplinary and diverse. So on the surface, to look at the team, you know, sometimes that we submit to a problem sponsor, they're like, I don't know. How do I have a physicist and, you know, somebody from the Kelley School of Business on the same team, right? How do those go together in computer science? But we recognize when you put just these bright minds together that have kind of the intangible pieces of the clay that make them up this great person, and put them onto a problem statement, that their outputs are typically fairly high and or exceed what some of their colleagues would put forth if they were just from one discipline. So as far as kind of the engagement, you know, at IU and what those next, 12 and 18 months look like, it's really about bringing more NSIN programming, to the university, connecting it to all of, my 30 plus DoD customers, and really creating that strong pipeline. Because one of the biggest things, and I was on a panel last night, one of the biggest challenges, in DoD is creating pathways to service and access to academia. So again, NSIN doesn't, we've got a good portfolio of programming. We're also completely open to creating new programming as well. So it's one of the things I appreciate about the organization is our ability to recognize or work with our collaboration partners and universities and say, hey, what we've got is working great. We're going to continue to engage and step and repeat that and build that pipeline. However, if we need a new program that's pointed at a problem sponsor, we can create those engagements as well. So we truly have to be nimble on the scene. And again, that's why the program directors, the university program directors are kind of sponsored by our university partners. So, I'm immersed into the campus and meeting the faculty and the students and trying to find out, do their capabilities align to some of those problem statements as we continue to pull them forward.
We have a few questions. One I want to direct to you, Jeff. You mentioned a facility that perhaps will be available in the future. Can you elaborate a little bit more on that? And the question is, will that be located in Bloomington?
Yeah, definitely located in Bloomington. And the idea of the facility is essentially to bring together faculty, researchers, students that are inclined in the area of applied potential DoD research, as well as customers. And so those customers are essentially the DoD itself or non-traditional contractors that are interested in participating in a research project for an outcome. Much of DoD research is applied outcomes. So this isn't really basic research just for researchers. It's meant to deliver solutions that the DoD or contractors are interested in. So that's one of the motivations for actually having it off campus, is that it would be a better installation for being able to connect with outside contractors from the university.
Then that leads into the question, another question, which I think maybe Mike, you could take, and that is, can local businesses get involved with the partnership? Is it more focused on academic? How can local businesses, perhaps defense contractors or those who want to get into defense contracting, can they be involved in this?
Absolutely, full stop. And we're trying to connect with those entities. And the facility that Jeff mentioned is part of that kind of strategic plan, right? We have to have a facility and an environment that allows and enables all of that kind of stuff to happen, right? So we must engage and find these non-traditional defense companies who may or may not even be doing defense work right now, but we want to try and find them and their capability and get them involved to the extent that they're interested in or want to be part of a team. So absolutely, entities who are non-traditionals or set-aside companies can participate. They can partner and team through their own capabilities, and they can bolt on to other entities that would broaden their potential delivery and engagement with the university. Because again, there's that in these teaming scenarios, there's push-pull, whether it goes in through funded research and or an entity that reaches back to the R&D available at the university. But absolutely, yes, please get involved. We're trying to find you.
Another question that comes from India, the person is writing that they are interested, can people who are overseas get involved in these programs, or is this strictly in the continental United States?
So yes, with an asterisk. So depending on the problem sponsor and the topic area, there will be U.S. citizenship required. And some of our problem statements that we work on are completely, unclassified open source. And those are open, internationally. So one of the things that we like to do in some of our communities is just that, where, we will have an open source discussion in what we call the DIN, or Defense Innovation Network, create a community around a topic and essentially, crowdsource what a solution may ultimately look like. And once it gets to a point of a potential delivery, then it would be required for U.S. citizenship and or a U.S. entity that would be the delivery partner for our DoD customer.
And then I have another one. I believe this is going to go to you also, Mike, and that is about funding. How long does this funding last? Is this, I'll elaborate a little bit on the question, but is this a one-time thing? Is this ongoing? Is it, how does this funding work for all of this?
So a number of different ways. So as it pertains to IU's NSA 2 award, that's a multi-year contract that we can get increases on the ceiling or the spend amount and the duration. So the period of performance, we're looking to continue on with that, essentially on a multi-year engagement. Other kind of funding paths, there are a number kind of in the NSIN portfolio, and I certainly won't get granular on each of those right now, but as far as to the university, multi-year additional acquisition paths, and to try and oversimplify this, once you have the contracting vehicle, right, that's the proverbial license to hunt. So that's the single most important thing, is to have the contract vehicle, which actually allows you to do business with the federal government. And then I would also give a kind of a mention to one of our, or actually two of our partners, and I'm on a session this afternoon with them. Also locally, you have the Naval X Tech Bridge, who does tech scouting for Big Navy. They have acquisition paths, and then also at NSWC Crane, you have a consortium manager who has a contract vehicle called an Other Transaction Authority. So depending on the entity and or the research that you do, sometimes your early stage step is find out where you align and ensure you've got an acquisition path, and that way you can actually do business.
And Memo, if we can ask you a couple of more questions, going back to kind of the students that were involved, and you mentioned that they became, they kind of got out of maybe their comfort zone and tackled some areas that weren't of their expertise, got interested in some defense. Is this, how is this changing kind of what you're doing at IU, and how are you able to get more students maybe interested in something that they weren't necessarily dead set on? There you go.
Yeah, I think it's a great question. I would probably piggyback on Jeff's statement that students nowadays, in particular with technology, get excited about producing and making things quickly. And so success stories always draw at least some attention. And I think word of mouth probably is one of the strongest mechanisms of advertising. So I have no doubt that each of these students are sort of peacocking and saying, look, we started on a project and we finished doing something more than what we had imagined. And now I have these skills and understanding of a parlance that I was unfamiliar with. So I think just the students themselves is enough of a to incite interest. But I try to bring some of this to the classroom, not in its full form, but we work on problems. Let's say you have a Roomba type machine that needs to clean a house, and it only has a particular amount of energy. How does it find its way through the house to most efficiently clean? So there's a lot of interleaving of I think a work that you get to do that you can bring back into teaching and in research as well, because as I said, the engineering aspect, and I'm so glad we have an engineering school now, says you've abstracted away all the problems. Now you have to sit squarely and meet them head on. And so while this works good on paper, you have to do something different in the wilds, and that's to me just as exciting. So and as a data scientist, I like big data and making smart decisions based on that data.
And Jeff, as you look at this program, maybe 12 months, 18 months, several years down the road, what do you hope the outcome is in the near future and in the future in general?
I think from a university point of view, you're always interested in a few aspects of seeing your university grow. One is student engagement, workforce development, as well as research projects in a given space or a given direction that have impact. So I think the idea here is that with the XForce program and some of Mike's undergraduate activities, that will really help both interest students, increase the number of students in the program, as well as change the landscape for workforce development in the area. And then on the flip side, on the DoD research component side, if there are available students, as Memo pointed out, that excites faculty and generates research teams that are interested in tackling new problems that no one has tackled before in the DoD space, and definitely not in our region or in our area. And so I think both of those components will allow the ecosystem to both grow and then merge together to generate something where problems can be brought in and people and outcomes can be pushed out. And I think that is really what we hope to see.
And Jeremy, let me just touch on that for 1 second, please, because one of the things that both Memo and Jeff have kind of connected now is these teams and the students, and I mentioned kind of pathways to service, but if I look at Memo's team and how they become feeders and enablers in the follow-on programming, and for the students, pathways to service opportunities. And by that I mean, how do we get students to serve in national security, but not necessarily have to go and put a uniform on and serve in uniform service. So you have one of the students from Memo's team who's actually now being recruited by NSWC Crane for a government position post graduation. So it gave her an opportunity to see the problem statement, work with some of who ultimately may be her coworkers in the future in a program office. So it's a fantastic way and a light touch for students to gain access and see what a day in a life may be like and what the opportunity may be like actually working for the government. And then also Pathways to Service means, those students who have that entrepreneurial itch, right? And they want to be part of an actual entity. They want to graduate, be part of a company that's on a solution set and delivering solutions to a DoD customer. And then two other components that are important here in all of this activity, and again, all that lives at IU and in Bloomington. The other part of that is you've got IU Ventures, which so we're always looking to partner with institutional finance as well. So I'm in close discussions with the team at IU Ventures. So as entities and technologies kind of reach different thresholds, we're introducing that to the investment community as well. So when we look to seek capital or raise capital and investment, it's all here as well. And kind of the final ingredient to that is we have these new companies that will spin out. We'll get them credential compliant, engaged, contract vehicle. We're also looking to connect them to local entities on existing contracts. So last night, and one of the co-sponsors of this week with the Dimension Mill is a company called MetroStars. And they've been a tremendous local partner for us in our activity and are always interested in connecting to some of these early stage companies or newcos that come out of this programming, and how can they connect and align and potentially subcontract or put those entities on subcontract into some of their task order awards. So you've got this whole kind of ecosystem, and if you put on your collaboration hat, the opportunities are there and they'll flow throughout, whether it's academia, non-traditionals, large primes, and institutional finance. So they're all right here.
And Mike, another question that has come out for you, I believe, really on the tactical level. Do students need a technical background, either in coding or engineering, to be involved? What about students who are interested in the political and global aspects of defense?
So you don't necessarily need a technical background, right? Like I mentioned, we're kind of engaged and try and pull heavily from, the Kelley School of Business. So, and as I also mentioned, we're always interested in interdisciplinary teams and very diverse teams. So, the other side of that is try to get aligned to some of the activity and some of the teaming opportunities to see where you kind of best fit. But the opportunities are there for any of the students.
Right, and we have about 8 minutes left. Maybe if we just go around and each of you, if there's something that I haven't asked or that the audience hasn't asked that you'd like to talk about, this might be a good opportunity to do that. So whoever would like to jump on that, go ahead and start. You're muted, Memo. There you go.
Yeah, what I would say is the landscape for academia is changing. Wall Street had a wonderful article a couple of years ago about how it needs academics need to engage outside of academia, and I think this is one of the most exciting ways to do that, because I think we, with the military, the government, share a history of bureaucracy and sometimes getting bloat. But I think what's happening is you're seeing that the best of both of what we can do is producing something that's remarkable. So making us do something practicable, I think, showing that spending time contemplating about problems and doing basic research does have results. And that's what I'm excited about. And also what Jeff and both Mike said, I think attracting more students to engage in this type of line of work is needed, and make them sensitive to that there are other things out in the world that they should be exposed to.
Jeff, any thoughts from you?
Yeah, I would say that I think the most important feature of the NSA2 opportunity through NSIN is basically it's an open doorway to be able to develop new activities that we haven't really had before. And it's an opportunity to interact with DoD customers and others that are working on DoD problems that maybe need our help in solving some of those problems. I think that has relatively been close to us in the past just because of the nature of our programs and the nature of the sort of what I'll call new collaboratorium. And so now it's going to give us an opportunity to interface with people. And I hope that the non-traditionals and small companies, et cetera, also look to participate both in getting solutions, but also in helping, broaden their horizons to tackle new problems and new opportunities that come forward, not just what they do today or did yesterday. So I think there's a new opportunity on the table now to really expand all of our capabilities.
And Mike, any other thoughts?
Yeah, we're no kidding trying to move at the speed of business now. And I recognize anybody who's done any defense contracting work or research, it is notoriously slow and ominous to get through just the administrative part. So part of my role is to really try and blow that up and be disruptive to this acquisition process. So I'm looking to engage in the ecosystem with faculty, academics, non-traditionals, primes, and connect and start to try and form as many teams as possible. We're also trying to fail as fast as we can. And again, using the connection to the taxpayer funds, we want to fail fast and fail often. And we want to curate down those solutions so the successful ones can scale and get delivered. The other thing, again, just selfishly, just to let everybody know that our XForce Fellows recruiting period is going to open in about 3 weeks. So through all my IU partners, you'll start to see the problem statements that are available and how to apply and all that great stuff. So if you are interested, please, take a serious look, consider submitting, joining teams of your fellow students and getting on one of these problem statements. And again, just as I move around campus, I do spend a considerable amount of time at Dimension Mill there and the Mesh lab on campus. So I encourage anybody who's interested to connect, please. You can just connect with me on LinkedIn and or send me an email, and I look forward to engaging, getting to know you, and bringing you into some of the fold.
All right, any other final thoughts? I know we could talk all day about this, but I think we are almost at the top of the hour. So Melissa, thank you very much. And thanks to our panelists for joining us today, Mike, Jeff, and Memo. And Melissa, I think we can send it back to you.
Thank you, everyone, for a really nice discussion and some really nice questions from our attendees. Thank you very, very much. So before you leave our session at 2 o'clock this afternoon, we have Purposeful Ecosystem Collisions, another NSIN panel that's going to have NSIN, the Midwest Tech Bridge, and the National Security Tech Accelerator on there. So another really nice discussion. And we hope to see you at 2, and check out the Mills website on our events tab for all the other events happening this week. Thanks for joining us, everyone. Bye.
Thanks, everybody.
Thank you.